G'day guys, haven't done a video for a while because I'm waiting on parts to come in, and without the parts it's very difficult to make a video with any new content. I mean, I could waffle on about all sorts of things, but you probably want to see what can be done with these detectors. Anyway, about the GPX 4500s and serial numbers, I've got a couple of detectors in, and they're both 4500s, but they've got very different serial numbers. So I've had a look at them, and I can tell you some things about the serial numbers. Okay, we've got this one here, this 45. These came in for basically good going over inspection. People want to go out in the middle of nowhere, and they want to make sure their detectors aren't going to stop working. So we go over the whole detector as such. Anyway, this detector here has a serial number. There's no like A, B, C, D, E, F, G's on it. I've seen these before. It starts off with 100 and then the number, which is usually 100 followed by a 4-digit number, unless they make millions of detectors, and then it might have an extra digit. But this is a 4500. I don't want to. It's got names and things on it. I don't want to advertise people's wares as such on the internet. So I'll just fire this up, and you can have a listen to it on the test coils. I'll just see how far it detects. Under there it goes. So yeah, I think I'm far enough over. You can probably see what I'm doing. So put the front mylar in. Every time I move these detectors, I take the mylars out so as to not stress them. And it's so cold here, everything's hard to get in when it's pushing these things in for some reason. As soon as it gets cold, it's hard to push them in. There's a fair bit of pressure I'm putting on there. Anyway, we've got the front and back in. I've got a microphone near the speaker here, so I'll leave that right there. It's probably making all sorts of horrible noise as I do that. Okay, I'll move that over there a little bit, just in case that the detector makes noise into the microphone just by electromagnetic coupling. Okay, we'll use the double coil setup, 2 cables into 1 plug. I'll just check the settings. I've already checked these, and I'll probably left them exactly how they should be, and they are. They're in normal timing, so we'll do all our tests in normal timings. So the switch there somewhere. Now I don't want that on. I've already done frequency scans with these, so they should be somewhere operating with very low noise. A standard setup. Everything's just bang in the middle, because these are just dead standard detectors. Nothing special about them. But up here, because I was doing a lot of testing, and you can see up there on that ruler, I put a new one there. It's got another 10 centimeters on it because I kept going over the top of the ruler. The more improvements we got out of these detectors, higher and higher and higher and higher it would get. And yeah, it's just hard, trying to say, oh, that's going 36 centimeters or something like that when you run out at 30. So anyway, we're up to, what have we got up there? It goes to 40 now, and I had to put some white paper behind the ruler because it's actually black writing on clear. You can't read it. As soon as you've got anything in the background, it distorts it, and you don't know what's what. Anyway, we'll use the old trusty ring. It's in fixed. It's basically how it's been. So there's a ring test target. I use that all the time. This ring, by the way, that's compliment to the ex-wife. Anyway, and this ring here is compliment to the new one. But I don't wear it because if I have this on, guess what happens? Every time I go near the coil, it'll go woo, woo, woo. So I can sit there. Anyway, there's our ring. This isn't fixed. It's not in tracking or anything. So we'll go over it and see how good we get it. And I'll just call it out. So this is a 100 and plus 4-digit serial number 4500. I'm at 30. There's a bit of noise there. There's always noise. Absolute put out at 31. It won't go above 31 centimeters. Dead stock standard. Just standard ring. So that's that. Now I'll get in here. I can try other modes, but everything's a percentage of normal timings on a larger target. So, you know, if it's going to be, if I go into enhance and it's 25, you know, it will be the same on any other detector that, you know, if the other one does the same, it'll be 25 as well. So everything's in relation. So it's not going to change anything. It's not going to have more performance in different modes. You always look at these in their normal timings. It's probably a standard. You could say, oh, well, I'm going to test them all in enhance, but that's limiting maximum depth anyway on larger targets. I'd rather try and maximize it as much as I can on larger targets, and usually it just transfers through to all the other modes, except on 5000s where if you maximize normal timings, it'll screw up fine gold mode. So that's because it's a fast mode. You do too much gain, or clock the frequency too fast. Fine gold mode will just go into the descents. It just locks up the front end. It won't work. It just locks everything up, and it just can't switch fast enough. Mainly, I have also found, I might as well tell you this too, when we have the problem with some of the 5000s, well, we don't have it anymore because we got around the problem, but when fine gold is getting desensed, it can also be caused by the coil. Where we have found problems, it's not problems but issues. No, it is a problem because it stops the thing working. Okay, we're doing some SDC 2300 coil swap overs with the dongle, and there was one flat wound coil, one of the newer ones, a flat wound. I won't say the manufacturer just because I just don't want to. So if it might be with all the flat wound coils or just one, but I have put this. I've used advantages, 12-inch advantages, work beautifully. There's one of the flat wounds, I think might have been an elite or something. I can't remember. It's a while ago. It worked properly, but we had a coil come in and hooked it up, and it was just a bucket of noise. You touch anything, it would sound off, and I don't know why. If the coil might have been possibly faulty, I don't think so. I think it's to do with the way it's wound and the way it reacts. There's something different. It might be even the Litz wire has gone to a thicker gauge, as in the wire stranding size, and that can cause an issue because those detectors are very fast. They can, if you got well, you know how sensitive they are. If you got wire or a strand of wire that's got any thickness to it, probably thicker than half a pin or something like that, it'll sound off on it. And the same thing if it's own cabling. If the wire in the cable, just say in manufacture over in Asia somewhere where they make this stuff, say the inner core, it's meant to be lit wire, and they didn't, for some reason, they didn't put a coating on the inner wires, and they were all touching together. That would sound off like crazy. You probably couldn't even use it. And same would go for the outside as well, the outside spiral copper on the coil cable. If you'd think though that there's enough spacing between the wires, it's sort of a loose sort of a thing, that if it didn't have a coating on it, it'd be probably enough wires separated anyway. But then again, if they were touching, it would cause an issue. It's just a diameter of wire size issue. And like I say, to test your coils, test your cable to see if it's reactive. Just hook your detector up with a different coil on it, and just get the other coil wire, not the end piece, in the middle somewhere where there's no big lumps of metal, and just go over the coil. And if it reacts, more than likely, it might react a little bit, but if it's really screaming, that you've got a serious problem. So, because any bend in that wire, it's going to change and it's going to cause noise in your detector. So just be wary of that. Anyway, that's the noise level we've got at the moment, just this background burble. And last night there was no noise, and as soon as the sun comes up, bang, we got noise. And it just, to me, it's saying, well, it's either grandma next door's got up and started watching her old Valve TV set or something, or it's more than likely, I suspect it to be solar system, solar panels, crappy inverters, just generating spew into the mains, just re-radiating. I know for a fact some of those solar systems out there are just noise generators. Um, you get little tiny fractures in the solar cells, and it arcs and it radiates across the whole spectrum for about 4 house blocks. Even moisture on insulators on the power line, same thing. Dust build-up, sitting there, zap, 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 or just a continual corona effect. Just that ionization, you can have, AC just dribbling across. It's very slightly conductive, but if it's out the front of your house, you're going to turn your detector on, you'll know about it. So, this is well, it works really well on the detectors I do. This quietens them right up because I balance the dual channels in the detector specifically, so they're absolutely matched. These have a bit of a bit of play in it, to put it mildly. And if it's not dead matched, suddenly you're not getting a full cancellation. So if your matching's like this, you'll start getting noisier and noisier, and then it'll be blowing you out the room. So everything's going to be electrically matched. And just because of the input of these, one channel is basically more or less floating, and you've got to rely on the damping in the coil, or if you put your own resistor in the plug on that channel, that the separate channel which hasn't got the transmit on it, because of the way that's set up, and because you've got the transmit and then you've got the switched damping resistor and everything coming in like that, that causes an unbalance too. You really want both channels on that hard, but the thing is, there's a mismatch there as well. It's just because that joining it here down the circuitry is a bit of difference, even on the 4053, get it right. There is the resistor network around that, and it doesn't give correct 100% matching, to about 0.1%. It's not like that at all. So all that can be improved. I've got some new parts I'm waiting on. It should be a massive improvement for these detectors. It should be absolutely a massive improvement for the 5000 too, because some of the bits I've got coming in should be able to run at really high speed, and we shouldn't have any time lag in the way these parts work. Any sort of delay, which we'll just classify as slew rate, that's what they call it. It's how fast it can go up and down in a given time. You know, some of them they go, oh, and some just go smack, 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 and they cause overshoot and all sorts of things as well. So yeah, you can't just go high speed and hope for the best. Everything's going to be fine-tuned for how these work, and then you'll get the noise out of it. Anyway, that's the 100. I'll get on the other detector. I'll turn him off. God, that is so hard to pull out. And so is this coil plug. As soon as the weather goes cold, everything just bites. And that's hard as well. It's never that hard. So always keep that separate. If you're mucking around with these things, keep the mylars not plugged in, because if you drop it and it pulls on it, it'll break the mylar. That, for those who don't know, the goldy looking plasticky things are copper trace on mylar film. That's what they are. And yeah, don't stress them. They don't like it. Anyway, put him back in the box down here. Oh, it must be coffee time. Oi, 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 oi. Thank you. Yeah. Good, you're on video. You want to go on video? No? Run away. Yeah, must have thought I was talking to myself. Okay, where's the other one? The other one's here. No, it's not that one. It's this one. Okay, another GPX. And it has a name on it. We're not going to show that. This one is a B8000 and 3 digits after it. So a B8000. So what we're going to do with this one, we're going to fire this one up and see how it goes. See, if you actually pick it up like that and just don't, someone's done a bit of a hatchet job on the wires on that too, on the coil connector there. But anyway, I hope it wasn't the owner. But yeah, you got to be careful. Yeah, it's got a lot of broken strands in there on the ground wire, so no big deal. No big deal. It'll still work okay. Dear me. Okay, and yeah, I'll just plug this in. Plug it all in. So this is a different serial number or different series of detectors. Now, I did the check on these things. Both of these detectors have a gain of 48 on the front end. Both are exactly the same. Because I didn't want to mistakenly get one with a gain of 34 and put that up. Like I say, these things are tight. Jesus, this has had some work done, I tell you. Like, it's been used a lot. It is just filthy. Anyway, stick that in there. Plug in the coil. Okay. Turn him on. Yeah, it's exactly the same as I left it. It's all factory standard. So I don't know if I got that in on the bench. Now, this one's more noisy. But what I'll do, I'll let it do a frequency tune. You hear that chirp as it's scanning? That's harmonics of some fundamental frequency that's interfering with the detector. Made no damn difference. Okay, we'll see how it goes anyway on the test. I'll just stick that up there. We'll see where we go. Puts out at 31 as well. I can't get past it. There's just the noise coming in is probably having an effect over how far you can detect a fringe type target right out, in the weakest part of the electromagnetic field. And what gets back to the detector is very, very weak indeed. We're just talking fractions of a nanovolt. But this series detector, I don't know if it's this detector in particular or this series of detectors, is more noisy. It just is. And I did a frequency scan on it, it's still noisy. And it's dead stock standard. So why that is, don't know. What it usually is, and I'll tell you, I know what it is. It's the old matching. Because even on the input stages of these detectors, they have facilities to fine tune the offset voltage off the input devices, and it's not hooked up. There's no provision for, well, the ICs have it, but there's no provision in the detector, track work or whatever. Those tracks, the pins off the ICs just go onto, little pads, and that's it. It doesn't go anywhere else, so you can't do it. If you wanted to fine tune it, and if you had, say, a double D coil, not that a double D coil is a good thing to do it on, because the windings on a double D coil are completely out of kilter with what you want to do. Everything has to be identical. So if you got a double D coil, and you just say, for instance, that your transmit side winding is 20 turns or whatever it may be, and then on the receiver they've used a thinner gauge wire, so you've got a resistance or reactive mismatch anyway, because the extra capacitance in the windings, and also a resistance mismatch as well. And they also run extra turns, so try and get more signal into the receiver. The more turns you have, the more pickup you have, the more ability to pick up those tiny signals. But then again, you have a problem that if you have too much windings, the way it actually works, everything, the frequency will drop down, and its self-resonant frequency will drop, and the extra capacitance, just interwinding capacitance, any fast signals, like they want to do this, suddenly you're going, can't get past that capacitance. It acts like a filter, high frequency filter. So, and also the damping has to be exactly correct. The damping on this, what is it, 390 ohms? The damping in most double Ds is around 600. There's mismatches all over the place. So you can't use cancel mode with a double D coil and say, well, it's perfectly cancelled. It's not. It's like this. And that's just going to let tons of noise in. So if you actually did the offset on these and you put in the circuitry to do it, you could possibly, I don't know if anyone would do it, because it's running a double D coil. Yeah, it's going to work. It's going to be. It's not in full cancel. It's not cancelling. it's going to work. So it is what it is. But if you say you wanted to use cancel mode uh, under some radio tower or TV towers or near close proximity, or anything like that, even power stations, power lines, ground return power, all that. If that's a single wires, by the way, that go out in farmland, the return is through the ground. So be wary of that. Anything between wherever that goes to and near that wire, the ground is really just full of 50 hertz or 60 hertz, wherever you are in the world, and your detector's going to go nuts on that, just on that ground return. And that's why sometimes you get ground and you're out there and you're going, wow, this is really noisy. It's like the ground's charged with interference, and it's not that. If you've got an underground, I'll let you in on trade secrets. If you have an underground water channel, say an old river that somehow, or old creek or whatever, that's remained relatively moist and very conductive, your return current or from those single wire power things, they're 22 kV too, I think, or 2200, one or the other. Don't touch them, don't go anywhere near them. I've seen earth moving equipment like excavators touch them, and the tyres all burst into flames. So you don't want to do that. So anywhere where it's a conductive channel, it just doesn't say, well, I'm on the ground under the wire as a return path as such. If there is an old channel or any mineralization channels or anything like that, well, guess where the return's going to go? It's going to take the path of least resistance, and it will follow an old channel. So, and I'm going to tell you a story about doing this. You might say, oh, well, it's an old paleo channel down there. It might be full of gold. Yeah, great. It might be too. But be careful with this earth return stuff. Because I can tell you, when they put in the pipe work for that, it was years and years ago, big metal pipes they put in, what was it, Melbourne to somewhere. Melbourne to Echuca or somewhere, I don't know, somewhere up that way on the Murray River. They put in a massive water pipeline all the way down. And when they had sections of this pipeline put together and there was sections getting done over here, what would happen is that if you touched a section here and it was like, bring it in, like that, if you grabbed it, there's a good chance you would have been killed, even though it's not touching any power anywhere, because that was where all that earth return wanted to go through the metal pipes, and even though it was like kilometers or miles away from those wires, there were people, I know people that, this is in the days of, I think it was the Rural Water Commission, that people got freaking zapped really bad, hospital cases and all sorts, burnt fingers, and it was because it was what was it, 100 kilometers long or more, maybe 200 kilometers long, all these sections, and all of a sudden, because they're very, very low resistance than compared to the ground, they wanted to have all the current from these wires. Just said, oh, I'm going over there, I'm going down that. It's really good, it's a good conductive channel. But yeah, so be careful with paleo channels too, if you do find them, or very conductive channels anywhere near those wires. If that wire is going through, just loamy sand soil as its return, it's going to be massively high resistance. And what's going to happen is that it's going to look for some other conductive means, and we'll go down that way. Now, there has been cases where barbed wire fences have become charged up that run parallel with those wires, not even close, but there's enough capacitance there to build up a charge, and you touch it, whack. So you might think it might be a cow fence, electric fence for cows or horses or something. It might not be. It might be coupling in. So you just got to be careful too. If anything on one of those wires is grounded, or even grounded both ends or anything like that, it can say, well, I'm not going through the ground anymore. I'll use it as my conductive path back to the generator. So you can get a whack and a half off things like that. And if you find a paleo channel, what happens if you start digging it? Say you use an excavator and you dig out the middle part of it or something, right? And this bit's charged and this bit's sort of not, and you want to get in there and touch. You are now the conductor. Be careful of stuff like that. There's a lot of materials, like you'll have all your wet clays that are fairly conductive. Scrape it all out. What do you got? Especially if you're on bedrock. you know, you are now the wire if you get in there and touch it. And just got to be wary of stuff like that. Especially the higher the voltage, the worse it is. So I can't remember if it's 2200 or 22,000. I don't know. To me, it sounds like 2200 might be more accurate. 22,000 sounds like a lot to stick up on a little pole and a little insulator, but I think it's 2200. I used to do a lot of work down in the power station areas and that, and I remember down there one day, and they had these massive pylons near the coal power generating stations, and I remember looking up and I could hear this crack, 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 crack. And one of the guys working there, I said, how many volts is up there? He goes, oh, that's 500,000 volts. What? Yeah, it was jumping the insulators. So, yeah, dangerous stuff. Anyway, we got this bucket of noise sitting there. I'll just kill that. Yeah. Coffee comes in the middle of videoing, but anyway, that's all right. And because it's about 9 degrees here, everything's chilling down fast. So there's the serial numbers on those detectors. I'm going to find out why this one here does exhibit more noise, and it could be a mismatch. It could be, look, what happens in these detectors when they start going noisy? Things like that. I'll tell you what I have found. The diodes. I'll poke at it so you know what I'm talking about. Probably can't even see it, but I can't make it bigger. Hang on, I'll drag this along a bit. Whoopsies, don't hit that. But diode here, diode there, diode under there, diode, sorry, say dia. Yeah, if they start dying, they're dias, aren't they? Diodes. But these can go leaky. You have to put reverse voltage on them and just use a high value resistor and stick 200 volts across it. Not that you're going to do that, because you'll probably electrocute yourself. But you can have you got to take them out of circuit to do it too. You got to undo them. But you can measure these to see if they're leaky. If they're leaky, they're going to make a heap of noise. The other thing too, this MOSFET here, the IRF 9630 for memory, these are operating very, very close to their breakdown voltage. You can get these, after a while, they suffer from something we call metal migration. It's basically ionic effect inside the structure. The metal ions move and they get very close, and you can get avalanche problems in these. And it sounds exactly very, very similar to a breakdown of an insulator on a power line. If you ever heard on a car radio or something of that nature. Car radio, what's that? AM radio? Yeah, we're talking the dark ages, aren't we? But anyway, they can avalanche. The other thing too is the capacitors can, if they're being used in high temperatures for a very, very long period of time, they dry out. They've got a very, very slightly liquid electrolyte in those, well, electrolytic capacitors, self-explanatory. And if these start drying out, all the transmit, receive, the ringing increases because it's a stop-start transmit power supply thing they use on the receive. And if it bounces around, basically loses its, the capacitor lose their, well, basically a high impedance. That's what we're talking about. Higher, I'm just trying to put it in simple terms. But if they start going higher impedance, which means they're not locked to the negative rail, and it sort of just bounces up and down. And that can cause all sorts of problems in the detector. What else can happen? Mainly, there's heaps of capacitors in there anyway, on various parts of the board. You got 3.3 volt rails, you got plus and minus 5, you got a 15, and anything on those rails where the capacitors start becoming a bit down the dumps on their values, what they started off with, that can generate problems as well. So, but if you want to change the capacitors, you really got to know what you're doing. You can't just heat the legs up and just pull it through the board. It will pull middle layers out and break, and you won't be able to fix it. So a lot of the stuff on these detectors is a specialized job in a way. You've got to really know what you're doing. You really do. But a lot of the other noise in these detectors too, it's just components. You know, they get older and older and older. And like I say, anything with voltage going through it with semiconductor junctions is very, very likely to have metal migration inside the devices over time. It's just the way these silicon devices are made with their impurities and things. They actually ionically move through the substrates. But anyway, don't really want to get into that stuff. But you know, if you want to do a really good job on these, yeah, you could change the caps out. It's very hard to measure these in circuit. There's devices out there that say, "Oh, yeah, you can measure it in circuit," but it depends what's hanging off it. You know, say if you've got a big bleeder resistor off it, or it goes into the circuit, it's all low impedance stuff. The capacitor won't be able to charge up, and it's going to bleed out. It's going to tell you it's a very low value, and it's probably perfectly fine. So don't believe anything like in-circuit capacitance testers to any great degree. I wouldn't. It's my opinion. Always check the wires, like on here. Even if it's holding by one strand, the detector's still going to work because it's only a small distance. It's like, you know, 0.0001 ohm resistor, but you know you don't want it to break off. But always check for that sort of stuff. Yeah, people who replace the wires too, make sure that they've used tin-plated wire, not just pure copper. It'll cause a big issue. You wouldn't think that would happen, but it does. I've found it. Yeah, they used heavy gauge copper, pure copper. So it was acting like big sticks of metal in there, and it just completely crashed out the receiver. I couldn't work out why they'd done such a good job redoing the cables in here, and the detector didn't work afterwards. Like I say, if you don't know, you don't know, and you'll be scratching your head. But anyway, that's that. I hope my delivery comes today, then I can make another video on that 5000 I'm doing up over there. That's going to be a nice one when it's finished. That'll be my own one. So I'll have a really top-notch 45 and a top-notch 5 I'll keep for myself, even though I've got plenty of 4500s. I can only use one at a time. So that's that. Anyway, I hope that was some educational benefit on the serial numbers of these detectors. My other ones are 45s are all modified, so I can't do any standard testing to these that come in as standard because it's totally unfair. It's going to make these things look like a bucket of you know what, and I don't think anyone who wants to be told their detector is, was shown their detector is a bucket of you know what, compared to something that's been completely modernized and you know, just big increases in performance. Anyway, running out of room. Like I say, remember the other day I cleaned up the whole workshop. Look at it. See, this is how quickly it gets messy. It just gets blitzed with stuff everywhere. People say, "Oh, why don't you put it away when you use it after you finish using it?" Because the thing is, I'm going to be using it again in 5 minutes. That means I got to get up and go and find it, and then I'll get no work done. People who think that electronics, you know, everyone who does electronics is totally messy, right? It's just the way it is. Now, I'll tell you this right now. Anyone who does electronics and has got a perfectly clean workbench and it's perfectly clean all the time is doing no work. That is nearly 99% factual. If you've got a perfectly clean workbench all the time, you're not doing anything, right? If you're doing a lot of work, a lot of stuff, and it's coming in and you got to keep on top of it, you got no time to stop and clean up. You're just doing job after job after job after job after job, you know, and you're half done and they're going to be put away and another one comes in. Can't stop. You got to order parts and all the rest of it. So you end up with a big messy workbench. It's just what it is. So yeah, I'm even encroaching on Chari's workspace over there because there's no room on the bench. Oh, yeah. Like even the floor's got detectors all over it again. So it's nothing you can do about it. It's just what it is. As the animal you deal with, and it's just a lot of stuff going everywhere all the time. Anyway, that's enough of the waffle on this. This was mainly just a serial number thing, and check it out. But yeah, I went on about detectors and you know what goes wrong. Just because this one's noisy. See, there you go. You talk about noisy detector, then you go try and analyse why it's noisy. Look at that capacitor there. Someone's banged that. It's got a bloody great whopping dent in it. See that? Right there. It's been smacked to beauty. Um, yeah, I think this board was left on its side. It's got flat spots there. So when they painted it, they put it up like that, I'd say. Maybe they put it down too hard and got dent in it. But it's only a mil and a half. That won't really affect it. Could puncture through the uh, you know, alloy material inside and short it, but shouldn't. But you know, just the way it is. Anyway, that's enough of a waffle. Catches.